If you build a synthesizer, then you have a choice of the kind of connectors and cables you want to use. And at the moment there is like three common kind of cables in use. It's either the so-called full-size jacks, there is the mini jacks, and there is banana cables. If you work with jacks, that means that the cable does not only connect the signal, but it also connects the ground or the reference of the signal together. If you work with a banana connector system, then the banana cables only pass on the signal and not the reference of the signal, which means that you have to sort of generate a sort of a extra reference connection somewhere in the system. They all have their advantages and disadvantages. The jacks are pretty reliable, but they're also quite big, and you end up with a fairly sized system. With the mini jacks you can make much smaller. You see that you can shrink down your modules to like 60% of the size. But the mini jacks tend to be slightly less reliable. The reason is that there is not really an official international standard of the measurements of these cables. So every manufacturer might actually be a tenth of a millimeter off in respect to another manufacturer. That means that with the big cables, that is actually in a percentage less a problem than with the small cables. Although these days, because these mini jacks have become very popular again, you see that the quality of the mini jack cables is actually improving slightly in the last 2 or 3 years. But there was a time when it was pretty bad. But with jack cables, and basically also with mini jack, but especially with jack cables, if you look at what is inside, I have an example here, and this is, you see that the cable goes in here, but you see that there's actually 4 connections to this. And you can see that from this connection, it connects to this connection if there is no cable, but if I put in the cable, press it in, you see that this connection here is broken and instead it connects to the tip. That means that you can make an internal connection by connecting all these switch connectors together, which you can override by pressing in a cable. This process is called normalization. And you would say that, for instance, the output of an oscillator is normalized to the input of a filter. That means that if you actually listen to the output of the filter, it is like it is sort of connected. But the moment when I press in a cable into this input, the sound is gone and this basically takes over. Now this is a bit confusing because there is something else that's also called normalization, and which is also very important, and that actually has to do with the translation between control values and physical units. Like, for instance, if you use a voltage, a changing voltage, to define the pitch of an oscillator, you would have to say, to increase my oscillator by 1 octave, I would have to increase my control voltage by, for instance, 1 volt. Or you might choose 2 volts or half a volt. It's arbitrary, basically. But there is a standard, sort of 1 volt per octave, which was actually figured out by Bob Moog in 1964. And that is sort of generally in use by everybody. And this basically is also a process called normalization. If you apply this to mathematics, it basically means what do you want your mathematical one to be in terms of control voltage or digital value or whatever. So for instance, you can say that if you want your voltage controlled amplifier to amplify by 1, meaning it would multiply by 1, meaning no change in level between the input and the output, you need 5 volts. Then that means that you have basically, that's also called normalization, whether that would be 5 volts or 10 volts or 1 volt. And these things, they work together because your control voltage that you use to sweep your oscillator by 1 octave might also be used to open or close your VCA or your filter. And so how sensitive your control inputs basically are to a specific standard voltage, that is also called normalization, which is a completely different thing from this kind of thing. So now we Dutch, we have much less words as the English language. We are very used to use the same word for many different things, and then depending on the context you just decide what is meant. So we're used to it, but maybe you British guys, it might be a bit different. I don't know. So, but what I'm talking about now is basically what we do with this connector. So, in this system there are already a couple of internal connections made, and there are basically a lot of so-called normalizations within one section of a panel. There's a couple of normalizations between the sections in a panel, and there are no normalizations between panels. And basically my idea is that the normalizations that you have between the sections will sort of turn it into like a voice, like you have an oscillator, you have something to modulate the amplitude, and you have a filter and a VCA. So if you normalize the output of the oscillator to the input of the filter, and the output of the filter to the input of the VCA, and the envelope signal to the VCA CV input, then basically you don't really need cables to sort of play in a traditional way with like a keyboard. But then there is a difference with many of the keyboard synthesizers, the analog keyboard synthesizers, is that you can actually override all these connections. So to be able to apply your own modulations, whatever you want. Which myself I think is a sensible idea. But of course every designer is free to do it in their own way. There's no laws or rule that tell you to do it like this or else you'll be shot. So basically the idea of this system is that you have sort of like 3 voices on top. 2 voices are fairly traditional voices, meaning an oscillator, a filter, a VCA to control your loudness, and an envelope generator, which is a module that produces signals to sort of open and close your VCA and sweep your filters and oscillators. And they are all 3 slightly different voices, so you can use them for different purposes. The difference between the first and the second panel is the choice of filters. As I already demonstrated this filter and talked about the twin peak, you see that there's already quite a lot of difference in these filters, making it different voices. And the difference with the third is that this has this other kind of oscillator and also turns it into a different kind of thing. So basically you have 3 little analog synthesizers here in the top row that are all slightly different in character and can be used for different purposes.